All right, go ahead. Start over.
Hi, James and Ann. This is Randy at Enviro Assist. We were doing your septic system inspection today. What we found is a 1,000 gallon septic tank. You can see it over here. We'll be putting together an aerial photograph or a CAD drawing so that you'll have all this mapped out. So the location of it right now is not all that important. Anyway, from the septic tank, sewage comes out, goes into a trench type drain field that will also be mapped out for you. The system has some limitations. It was designed to handle about 200 gallons a day. We do have tree roots growing into it that we're going to try and focus in on for you here. And you can see these tree roots growing right down into, if you see the orange down there, that is the piping for the drain field. You see it's full of dirt and roots. It's not obstructed everywhere. There is some drainage through the system, but there's enough obstruction in here that I would be uncomfortable saying it could handle more than 100 gallons a day. I want to go over the operation of the system real quickly. The septic tank is nothing more than a separating chamber. It separates solid from liquid. As sewage goes into the tank, the slow rate of movement through the tank allows sediments to settle out at the bottom, forming a sludge, and lightweight fractions, fats, oils, greases, to rise to the top and form a scum. If either the sludge or the scum go out to the drain field, it plugs up the piping and the stone around the field and prevents the drainage. We do see some evidence that the water level has come up too high in the tank and that some of the some of the scum may have gone across to the field. There's an outlet device in the tank that should retain the scum and keep it from going across. The fact that we've got such a significant scum layer here tells us that it is doing the job. However, the slow drainage through the field itself causes water to rise in the tank every now and then, and as the water comes up, the scum can go through the top of the outlet device and make its way out to the field.
Is that this?
That pipe sticking up,
Yep.
You probably can't see it very well in the video, but if you can, that pipe is the outlet device. It's open at the top. That opening is necessary for it to breathe so it does not airlock. But that's where the scum can get in if the water level rises too high.
Okay, good. Anything else?
The liquid fraction between the scum and the sludge at the bottom is all that should be going to the field. That liquid layer is full of bacteria that are anaerobes. The septic tank is anaerobic. The organisms live without oxygen. That type of organism produces a slime as a byproduct, and that slime encapsulates and protects the organism. If the organism is surviving in the drain field, that slime can build up in the field, plug up the pore spaces, and slow down the drainage.
Is that what we call biomat?
That's what we call biomat.
Yep.
In this case, we do not see a biomat layer. More what we have in this one is physical obstruction.
Okay, so no biomat. That's a good sign, right?
And that is a good sign.
However. However,
we don't think the field is getting much use.
Okay.
Again, I'd be hard-pressed to say it could handle more than 100 gallons a day efficiently.
And what would you normally push through a system on a daily basis?
Well, on this one, it was designed to handle 200 gallons a day.
Okay.
The average household is sending out 60 to 75 gallons of sewage per person per day.
Okay.
So, in essence, two people living with water conservation may be able to work on this drain field successfully. However, if you had more people than that, it would probably be difficult. This field I would not expect to last very long. If you had two people using high amounts of water, again, I would expect it to have some difficulty.
Okay.
And we'll be putting this all together in a written report for you.
All right, good. Okay.
And you can call with any questions later.
Perfect.
Thank you.
Thank you, guys.
Oh, no problem.